Hello students, welcome to another new video on Introduction to Field Effect Transistor, popularly known as FET. This field effect transistor is one of the very important solid state device which is very widely used in the fabrication of integrated circuits. In this video, I will explain what is a field effect transistor, what are the terminals of this field effect transistor, how it functions, what are the differences between a field effect transistor and a bipolar junction transistor, and also the construction of a field effect transistor. Let us start. The field effect transistor is basically an active unipolar unijunction three-terminal semiconductor device which can act as an amplifier. This is almost similar to your bipolar junction transistor, but a bipolar junction transistor has two types of polarities and two junctions. Here a FET is a active solid state device or semiconductor device which has only one type of charge carriers for its conduction, and it has only one junction. That is the fundamental difference between the FET and BJT. This FET was first conceptualized by Julius Edgar Lilienfeld in the year 1925. That means far before the BJT. But this man could not realize this concept of field effect transistor. After some time, people like Heinrich Welker, they could fabricate this device and they got their patent in the year 1945. That's why this FET is also popularly known as JFET, Junction Field Effect Transistor. Similar to your BJT, the FET has three terminals. The three terminals of a FET are source, gate, and drain. This is the circuit symbol of your FET. So this is your gate, drain, and source. When you observe or compare this with your bipolar junction transistor, which I have shown here, it is very much similar, and you can see here that source is similar to emitter, collector is similar to drain, and base is similar to gate. That's why I told you in the beginning there are many similarities between BJT and FET, especially in terms of the terminals. So what is the conclusion? A FET is a three-terminal device. The terminals are source, gate, and drain, whereas a BJT is also a three-terminal device where the three terminals are base, collector, emitter. Base, collector, emitter. I think you are able to see this clearly. Now, once you have understand the basic idea of FET, now let us see what are the important features of the FET or JFET. So, for this, let us first understand why it is called FET, field effect transistor. The current flow in a FET is controlled by the electric field between drain and source. Actually, how do you get electric field? When we apply some voltage. That means the current flow is controlled by the voltage applied between either drain and source, which is called VDS, or gate and source, which is called VGS. That's why as the current is controlled by the electric field, a existing between the drain and the source, it is popularly known as field effect transistor. That is one of the most important things related to FET. Now, by fabrication, FETs are small in size. That's why they occupy very less space, and hence they are widely used in the fabrication of integrated circuits. So, in the fabrication of ICs, FETs are more widely used, and also FET is less temperature sensitive than BJT. It's a very important point. What do you mean by less temperature sensitive? With the change in the temperature, the current in the FET do not change much. It is not affected much. That is, the effect of temperature is very less on FET when compared to BJT. And similarly, the drain current of FET exhibits a negative temperature coefficient. Very important. What is the meaning of negative temperature coefficient? As the temperature increases, the drain current decreases. That is why, because the carrier mobility decreases with increase in the temperature. So the drain current of FET exhibits a negative temperature coefficient, whereas the collector current in the BJT exhibits a positive temperature coefficient. This is another very important difference between FET and BJT. The reason being, with increase in the temperature, the mobility increases. That is another important thing. So to maintain the thermal stability of a bipolar transistor, we have to take special precautions in the design, which is called base ballasting or emitter ballasting. The meaning of base ballasting or emitter ballasting is nothing but, in a transistor, when you have a transistor like this, either for base or emitter, suppose this is your emitter. Assume that this is your emitter. What do you mean by ballasting? They connect some suitable resistors so that these resistors will maintain the current through the transistors constant. They maintain the current through the transistor constant. Emitter current remains constant so that it will not be heated up. That is, more amount of power is not dissipated. And if you remember well, there is a concept called thermal runaway. Therefore, that means self-destruction of a transistor. The BJT will heat up by itself and finally it will be destroyed. There is a problem. So to overcome this, in a BJT, we use this concept of ballasting. It is called emitter ballasting when I use these resistors at the emitter. Whereas such things are not required for a FET, because the FET is already stable. That is, temperature effect is very less. And also the FET has very high input impedance when compared to BJT. Hence, when you have high input impedance, high input resistance, you can easily connect them in parallel. You can connect them easily in parallel, whereas this is not the case with the BJT. If you want to, because the input resistance or input impedance of the BJT is not very high, when you want to connect them in parallel, you have to take some special precautions. And also another most important thing is the transconductance of the FET. We will discuss this in the next video. That is, it is the rate of drain current change with gate voltage. That means it is nothing but delta ID by delta VG. Yes, or VG. Gate voltage. So drain current variation with gate voltage is called transconductance. Similarly, you have studied in BJT also transconductance. But in the case of FET, the transconductance is nearly almost constant, whereas in the case of BJT, the transcurrent gain decreases drastically. Very important. Another thing, FETs have good switching time stability. That means they can switch in the digital circuits when they are used. So they switch from 0 to 1 or 1 to 0 level, even with, that is, with changing temperature. Even when the temperature is increased or decreased, This speed do not change. That is called switching time stability. But this is not the same case with your BJT. That is very important. That is, with the change in the temperatures, the switching speeds also changes. That is a very important thing. Now, once you have understood the salient features, important features of FET, now let us understand the classification of FETs. Normally, FETs are classified into two types. When I consider a FET, normally there are two types of FETs. One is called the junction field effect transistor. Suppose I call this as a FET or normal. So the normal name FET. So we have two types of FETs. One is called the junction field effect, JFET, junction field effect transistor. The other is MOSFET, that is metal oxide semiconductor field effect transistor. This is another very widely used, very important transistor or FET. So it is called MOSFET, it's called JFET. So JFET is one type, junction field effect transistor. The other is MOSFET. These are also known as IGFET, insulated gate field effect transistor. That means in this case, what happens is the gate is totally insulated from the other terminal or actually channel. So here suppose I call this as a gate. So in the MOSFET what happens? Suppose this is your drain, this is your source. So the gate is totally insulated from the channel. That's why it is called insulated gate field effect transistor. It is a better variant than your JFET, which we will come across in the coming videos. So FETs are normally classified into two types. One is your JFET, the other is your MOSFET. MOSFET means metal oxide semiconductor field effect transistor. Now let us understand the construction of a FET. It is a very simple process. Let us now consider the construction of a FET. Here I have shown the schematic of an N-channel FET. Basically a semiconducting bar of silicon. This is nothing but a FET consists of a semiconducting bar of silicon. Of course, it can also be either a N-type or P-type semiconductor. When it is N-type semiconductor, it is called N-channel FET. When it is a P-type semiconductor, it is called P-channel FET. So, for this semiconducting bar, what we do is suitable ohmic contacts are made at both ends. So, when I have a semiconducting bar, what we do? So, we'll consider a semiconducting bar. We'll make two ohmic contacts or metal contacts are made so that I get two terminals. So these two terminals, one will act as a source, the other will act as a drain. And in this semiconducting bar, at the lateral sides near to source, we dope a P-type material on both sides actually. On both sides, we dope P-type material. When you have N-channel FET, suppose I consider a P-channel FET, then I dope N-type material so that it will form a PN junction, and internally these two are connected and a single contact or single terminal is formed, and this terminal is called gate, and the voltage applied at this terminal is called gate voltage. The voltage applied at this terminal is called source voltage, or the voltage applied between these two terminals is called drain source voltage. So what is a simple construction? I have a semiconducting bar, and at the two ends of the bar we make two contacts, ohmic contacts, and you form two terminals. One terminal is called source, the other terminal is called drain. Near to the source terminal, we diffuse a P material on both sides laterally so that they diffuse internally and you make a single contact. That single contact is called gate. That's why I dope some material here, as you see here. So this will become your gate. So this is the basic simple construction of your field effect transistor. When you don't apply any voltage at the gate, this is nothing but a semiconducting bar. That is your resistor. That's all. Simple resistor. It is nothing but your resistor. When I apply a voltage between source and drain, the current or charge carriers will move between these two terminals. But to control this current, we have to apply voltage at the gate. This is the third terminal. Because of this, I have a three-terminal device. I have a three-terminal device which is known as FET. This is your gate. This is your drain. This is your source. And a very important point about the FET is always a symmetric device. That means the source and the drain can be interchanged. That means you can choose this as a drain and this as a source. You can interchange the source and the drain. But the only difference is during the fabrication, most of the times the gate, that is the P material dope, will be near to source when compared to drain. That is the only difference. So the gap between these two junctions, P-N junction, because this is a P material, this is your N material. So between these two P-N junctions, this is known as channel. This path is known as channel. That's why by diffusing a P-type material into an N-type semiconducting bar, we get an N-channel FET, or by diffusing an N-type material into a P-type semiconducting bar, I get a P-channel FET. This is the fundamental construction of your field effect transistor. So this I have explained in this slide, same thing. And this three-terminal device has many applications. Like it can act as a voltage controlled resistor, constant current source device. Like this, it has many applications in electronics. That's why I have also told you, based on your semiconducting bar, you can have two types of FETs. It is N-channel FET and P-channel FET. If you remember your BJT, we have seen two types of transistors. That was a PNP transistor and NPN transistor. PNP transistor and NPN transistor. But what is the difference? In the case of N-channel FET, electrons are charge carriers. That's all. Whereas in NPN transistor, you have both electrons and holes. In a PNP, both holes and electrons. That's why it was called as bipolar. That is the difference between these two. I have explained both the differences and construction also. This is a bipolar device, whereas it is a unipolar. That means though it is similar to NPN and PNP, two types. PNP means that is a P-channel FET, but not equal. In a P-channel FET, you have only holes as charge carriers, unipolar. That's why it is called unipolar. In the N-channel, we have only electrons take the conduction. Electrons take part in the conduction, N-channel FET, whereas it is a bipolar. These are the differences, construction, and brief working of your FET. So in the next video, I will explain how a P-channel FET or N-channel FET will work and how a gate voltage will control the current flow in your FET. Thank you. Good luck.